Example 1, describe the transformations that are required to obtain the following graphs from their parent functions. In the first part, we have y is equal to negative sine 1/4 x plus 37 minus 2. This is a sine function, and all the numbers here represent some sort of transformation. So if we compare it to the general form, we can clearly identify the values of a, k, d, and c. So we can see that a is -1, and the negative represents a reflection on the x-axis. See that k is 1/4, and when k is between 0 and 1, it represents a horizontal stretch by a factor that would be the reciprocal of k. So in this case, it'll be by a factor of 4, since the reciprocal of 1/4 is 4. D is actually -37, because if we wanted to rewrite x plus 37 so that a number is subtracted from x, it would be written as minus -37. So D is -37, and it represents a horizontal translation. (37 units to the left because of the negative. And finally, C is the number that's added here, and we're actually adding a -2. So C is -2, and it represents a vertical translation 2 units down because of the negative. Okay, let's look at part B. Y is equal to 6 cos -3x plus 22. Cos of x is the parent function. And when we compare it to the general form, again, we can see the values of a, k, d, and c. So a is 6, and that represents a vertical stretch by a factor of 6. K is negative. The negative represents a reflection in the y-axis. And the magnitude at an absolute value of k is 3, and when that's greater than 1, it represents a vertical compression. And the compression will be by a factor that's a reciprocal of 3, or 1/3. And then C, in this case, is 22, and it represents a vertical translation 22 units up, since it's positive. Notice how we skip D, because D in this case is 0, so we don't have a horizontal translation.